So inelastic collision, again, here's the bus and the car information. Completely inelastic means they stick together. Want to know the velocity after the collision. Okay. So, just like the last problem, we want to draw a diagram first. So we've got the car going east, and that's at 62. And we've got the bus going north. That is at 43 meters per second. And then they're going to hit each other and they're going to go off at some angle. I don't know what that angle is. And I don't know how fast that is. And that's what I want to know. I want to know both those things. I want to know the angle it's going at. I want to know how fast it's going. So once we've got started there, I want to write down the things that I know. So we're going to call the car object 1. And we're going to call the VW bus object 2. So I just start by writing down the things I know. So the bus has a mass of 700. It has an initial velocity of 43 meters per second. And I'm going to put the direction 2, just because since this is a two-dimension problem, direction is going to matter. I don't know the final velocity. For object 1, so for the Beetle, it is 570 for the mass. Initial velocity is 62. And again, don't know the final velocity.
They're going to have the same final velocity, right?
Say again?
They're going to have the
Same final. Yep, because they stick together. Yeah. So if you can make that connection, which is a connection you need to make, you can just leave it as VF and VF. Because they will stick together, they will be the same. All right, here's what I want you to do. I want y'all to get started. I want you all to start, see what you can do with this problem. There are 2 ways to solve it. I don't care which way you do. Okay, it's up to you. And I'm going to just show you one particular way. If you're having trouble understanding that way, I can show you the other way too. But there are 2 ways to solve this. What I want you to do is try to get started. I will give you a little bit of a hint here. You have to divide this problem into 2 parts. You got to divide it into the x direction and the y direction. You got to treat them separately. So, see what you can figure out. Huh?
I don't remember that.
No? If you're wondering which equation to use, we're conserving momentum. So if we're conserving momentum, that's this one. So set that equation up for both the x direction and the y direction. It's right here. Theta equals tan negative 1b over a. Okay, x. We're using this equation, P1i, P2i, P1f, P2f. for this in the x direction, I'm only using forward things in the x direction. That's it. I'm only using those. So for Ringo, that is going to be mass times velocity plus, now I'm going to do the bus. But the bus is in the y direction only. So the momentum in the x direction for the bus is 0. Then they stick together. When they stick together, they combine their masses. Okay? And that gives them a mass of 1270. And then the final velocity. It's the same final velocity for both. So that's why I don't have two final momentums. I just have one. But the thing we have to keep in mind is this is just for the x direction. That's it. It's only the x direction final force, not final velocity. Not the y direction, not combined. It's just the x direction. So 570 times 62, 35,340 equals 1270 v final x. Divide the 1270 over.
We do Pythagorean theorem on this one.
Yes, you will eventually. Okay, gives me a final velocity in the x direction. Again, it's just the x velocity, 27.8.
How did I get that so completely wrong?
I'd look here.
I did.
Yeah, does that make sense now? Okay, now I'm going to do the same thing for the y direction. So vertical motion. Well, vertical motion for Ringo is 0 because Ringo's going side to side. So the vertical motion is 0 plus the bus's value, which is 700 times 43, equals, now we combine them. 1270 times v final, but this is the y v final.
So you just do 1270 divided by the momentum for each thing.
To get the velocity, yeah. So this is 30,100 equals 1270 v final y. Divide the 1270 over. And I get a final y velocity of 23.7. All right, I'm not done yet. So I have the x velocity and the y velocity, but what the problem asked me to find, the magnitude and direction of both cars after they stick together. So what I have is I have the forward motion, which is 27.8. And I've got the vertical motion, which is 23.7.
Wait,
Now
I'm
what?
confused.
Yep.
Did you write that down wrong?
Did I?
Why is... Oh, never mind.
Did you figure it out?
I just don't understand.
What are you having trouble with?
Okay, wait. I just wrote it down wrong. We're all good. Carry on.
Okay.
We're all good.
We're all good?
Yep.
All right. Now, I found the forward velocity after the collision, and I found the vertical velocity after the collision. So now what I'm trying to do is figuring out the total velocity after the collision, and this is going to be Pythagorean theorem. Mm-hmm.
I got different y momentum.
What'd
So
you get?
Instead of 30,100, I got 31,500.
I got 30,100.
You did 570 times 40, or sorry, you did 700 times 43.
I read that as 45. That
There you go.
must be up.
There you go. All right. So now what I have is I have the 27.8 and the 23.7. If I'm trying to find the resultant vector, I use Pythagorean theorem, a squared plus b squared equals c squared. So 27.8 squared plus 23.7 squared equals c squared.
Okay, I got it right.
Okay.
Um,
When I do that, I get 1,334.6 equals c squared. I don't want c squared, I want just c. So square root that.
Is that 334?
It's 1,000.
Say what?
Okay.
Yeah, sorry. There's the one. And that gives me 36.5.
Okay, that one's actually easy. I forgot about the whole Pythagorean.
Once you figure out, right, once you figure out these, the rest of it is not difficult. The last thing we need to do is we need to figure out the,
the wrong
Will it say on the test what unit it is, or are we just gonna go?
no. Yeah. So like I won't have like 36.5 meters per second, 36.5 meters per second
No, I
squared.
mean like unit 5, unit 3.
It doesn't say, but it is in order.
Okay.
It doesn't say, but it is in order. So like
How many questions is it? 50?
ish.
So every 10 questions is the next unit.
Yeah, roughly.
Roughly.
Yeah, roughly. I might, if I remember and get to it, I might be able to put the headings on it for each unit.
Okay.
If I think about it or able to get it done. All right. Last thing we need to do is find the angle.
Where's the final velocity? Like, where's your answer to that?
Right here, 36.5.
Yes! Okay.
All right. Final velocity, and now we need angle. Here's the angle equation. Theta equals tan negative 1 of b over a.
And would be over the values of the vector.
Yep. So 23.7.
Wait, there's a certain. Oh, I know. What's B?
23.7.
So B is vertical, A is horizontal.
This one.
Would it be, if you get the value, would it be northeast?
I would just call it whatever the angle is. But yeah, if you said that, if you gave me the angle and said northeast, that's okay. But I wouldn't just say northeast. Northeast is a very specific direction, and it's not that exact specific for this one.
45
Are we
degrees.
gonna get the tan equation?
Yep. And the Pythagorean theorem. Okay, there you go.
That means it's, it went, yeah, it went 40,
So,
All right, any other questions on this one? Yeah,
So D is the Y, A is the X.
say again.
So B is the Y position. A is
Yeah,
the X.
and A is the X. Yep. All right, any other questions on this one? Okay.